We're in Tech Math 2, and we're in section 4-2. And what we're doing is we're graphing equations, and later on we get to do it more intelligently. In this particular section, all we're going to do is take some function, some equation that I have, and solve for both the x's and the y's, and make a table, and then plot those guys on an xy plane, and then say that that's my graph. So that's my plan. Wow. And I'm sticking to it. All right. And we have some nice examples, but the fact of the matter is that is all we're doing. And so we'll look at problem number 3. And graph the equation. So I got y is equal to 3x plus 1. All right, so I've got an x, and I got a y. I'm going to pick 0 for my x. When zero's my x, my y is going to be 1. When x is 1, y is 4. When x is minus 1, y is minus 2. Minus 2. And then I'm going to go and graph it. And I say, well, when x is 0, I'm at 1. When x is 1...
You're doing number 4?
No, I'm doing number 3. Oh, maybe I'm doing number 4. This is a 2. Is that what you're complaining about?
Yeah.
Okay, I have no eraser, and I have no other color than black. So that's going to be just one of those interesting things. My computer screen is shrunk down, and I haven't figured out how to fix that yet. Yeah, so we'll do our best. All right, well, so we'll do it again. We'll say number 3 in y is equal to 2x plus 1. And so we'll make a table. 0, I have 1, 1, I have 3, minus 1, I have minus 1. And then I put those points on. I got a point there. When I'm 1, and I'm at 3. And when I'm minus 1, I'm at minus 1. Really? All right. And then if I could change my color of my thing, I would. But then I'd put a line through there and say that's my answer. Okay. Now in another chapter, we're going to say y is equal to 2x plus 1. That's an equation of a straight line. Two points make a line. I'd only need 2 of them. And the y-intercept is 1, so it's got to go through 1. And the slope is 2, so every time I go over 1, I got to go up 2. But that's in a different chapter. We don't have to worry about that now. Okay, now we're going to look at number 20. And we have y is x cubed minus 8x minus 3. Okay, and then we're going to go x's and y's. Well, we're going to pick x is 0 because that's easy. I have minus 3. Then we're going to pick x is 1. So I've got 1 minus 11, so I'm going to be at 10. I'm going to pick minus 1. Minus 1, that becomes a minus 1, minus 4, plus 8. That's going to be a minus 4. As I get more negative, this thing's just going to continue getting more negative, right? Minus 1, this is plus 4. Minus 1, that's plus 4. Minus 2. Minus 2, so that's minus 8. Plus 16 for a 16. 16 minus 3 is 13. Okay, and then I'm going to look at minus 3. Minus 3, that's minus 27. And so that's going to be 0. Minus 3 is going to be 0. And as I get more negative, more, this is just going to get more negative. All right, now I'm going to look on the other side to see where I'm going to go positive. Well, I already know at 1 I'm positive. Why at 1 am I positive? That's minus 10, isn't it? Minus.
Yeah, that's mine.
Minus 12. How did I minus 8, 9, 10? That's minus 10. All right, so now I'm going to look at 2. Okay, so 2 is going to give me 8. Minus 16 is minus 8. Minus 3, that's going to be minus 11. And then 3, 27, that's going to give me a 0 again, right? That's going to be a 0. And that if I'm more plus than 3, I'm just going to go more plus. All right, so now I've got enough data points. Now I'm going to go and graph my equation. So at 0, I'm going to be minus 3. At 1, I'm going to be minus 10. At 2, I'm going to be minus 11. And at 3, I'm going to be back at 0. And when I get bigger than 0, I'm going to keep going up and be higher. Okay, so that's going to come in like that. At minus 1, I'm going to be 4. And at minus 2, I'm going to come up to 13. And at minus 3, I'm going to be at 0. So I'm going to come up like that and down like that. Boom. Now, those with graphing calculators, you can just put it in their graphing calculator and let it show you what it is. And that's the other way you graph things. So that's the way I would graph that. Now, because it's a third order function, I'd expect it to be in that type of a curve, go up, go down, and on the outsides go all the way to infinity quickly and never come back. So I would expect that. All right, going to do 51 next. Number 51. 51. A machinist needs to drill 4 holes. 4. Okay, there's 4. 1, 2, 3, 4. 4 holes, 2 inches apart in a straight line in a piece of metal at a 36-degree angle. Find the coordinates of the other 3 holes. Okay, so there's my XY plane. Here's my 36 degrees, and I want to find the coordinates of the 1, 2, 3 extra holes. Or am I doing it for all 4 holes? Oh, okay. So the first hole is at 0, 0, so that shouldn't be a problem. The second hole is going to be, if this is 36, what 54. So I've got 54 degrees on the other side, on this side, minus 54. Minus 54. Okay, so my coordinates are going to be, for point 2, the x component is going to be 2 cosine minus 54. And my y coordinate is going to be 2 sine minus 54. And point 3 is going to be at 4 cosine minus 54. And my y guy is going to be at 4 sine minus 54. And the fourth guy is going to be at 6 cosine minus 54. And 6 sine minus 54. Now all we have to do is just put those in your calculator. It'll be okay. And it looks like we want the answers to 2 significant digits. So even though I don't have a calculator, my computer does. So I can just bring one up. And I have sines and cosines. Okay, so I want 2 times cosine minus 50. Alright, so that doesn't do me any good. If I can't make the calculator work. Alright, so I want minus 54 with a negative sign, cosine. Okay, that's good. Times 2. Okay, so that's going to be 1.18. So point 2 is going to be 1 point, and again, I don't have an eraser right now, 1.18. And then the y coordinate's going to be 54 with a minus sign, sine times 2 minus 1.62 minus 1.62. Okay, the 3 guy is going to be at 4 cosine 54 plus minus cosine times 4, 2.35, 2.35, and the y guy, 54 with a minus sign, sine times 4, minus 3.24, minus 3.24. So basically that's double the other guys, right? But to get the 4 guy, I can't do that. Alright, so I'm going to go 54 with a minus sign, cosine times 4. 2 point, oh bummer. Did I do it wrong? Why am I getting that answer? (54) with a minus sign, cosine times 3, 1.67. Okay, so it looks like I have the wrong answer there. This is 2.35. And the guy up there is 1.73. 1.73 or 6? 6. And then,
That was right.
what was right?
2.35.
For 3?
It'll be double 1.18.
How come that's not what I'm getting though?
I don't know.
54 minus cosine times 3. 1.76. I'm in degrees.
Why
Why is it times 3?
Because I'm hosed.
Typical day, huh?
Yeah, typical day. Okay, so we're 4 times or 4 times. Now we want to be 6 times 6 times. Okay, so we were fine with a 2.35. This is 0.3, not 4 away. Okay, so this guy here we want to go times 6. All right. 54 with a minus sign, cosine times 6. 3.53. Uh, 54 with a minus, I hate this calculator, times 6 minus 4.85. Okay, well, I guess that's as good as we're going to get. And now we'll move on to section 4-3. And so we'll come back up to the top and say we're going to do section 4.2 and section 4.3. This is not working very well, is it? Okay. So we're in section 4-3, and we're concerned about a straight line. All right. Well, what does a straight line have? So here's an XY plane. There's a straight line. The straight line has a slope. And the slope is going to be the change in the y-axis over the change in the x-axis. So I've got some change in x, some change in y, and that's going to be my slope. Normally I use m to record it to be my slope. Look at that. I have an eraser. I don't believe it. I wonder how big it is. Oh, much better. All right. So that's the case. Now, if I know what x1 is and what x2 is and what y1 is and y2 is, if I knew that, then I can say, well, my slope is the change in y divided by the change in x is equal to y2 minus y1 divided by x2 minus x1. So we could say something like that. And that would be the equation on page 159. Now, also look in the front of your book, and you'll see that that equation exists in the front cover, which is something that you can open to during any test and look at. So the slope is change in y divided by change in x, using x, y1, y2, x1, x2, just like that guy there. All right, so now I've got a slope. So given any line, I ought to be able to figure out what the slope is, assuming that I got enough points. Now, we have an equation for a line, and we call it the point slope form of an equation for the line. And so if I have the slope, and I've got some point, x1, y1. That's all I know. and I want to make the equation of the line, then I say, well, y, something I don't know, minus y1 is equal to whatever that slope was times x minus x1. And again, when I look in the front cover of my book, I see that the point slope form is also sitting there. So if I know the slope and I know some point, then I'm all set. Then we have another form, slope y-intercept. So y is equal to mx plus b. So if I know the slope and I know where this guy crosses the y-axis, I can go and write down the equation. So I got this guy here, it goes like that, and I know that that point is 4, and I know the slope is 2. Then I can write down the equation line y is equal to 2x plus 4. All right. And then lines also have the option of being horizontal. So y is equal to 2. That'd be a horizontal line. Boom, boom. 2. Okay, and they also have the option of being vertical. It's an AL. Vertical. So x could be equal to 2. So I could have vertical lines or horizontal lines. Okay, so those are my options. And all things else, okay, so everything else is fine. Working on problem number 7. Number 7. I want to find the slope of the line passing through this. Okay, so I've got 5, 7, and I've got minus 3, 2, and I want to find the slope. Okay, so which one of these is x1 and which one of these is x2? It doesn't matter. Okay, whichever one I pick, it's going to come out right. So I'm going to say that this guy here is x1, y1, and this guy over here is x2, y2. And I'm going to take my slope is y2 minus y1 divided by x2 minus x1. So I'm going to have 2 minus 7 divided by minus 3 minus 5. And I'm going to have minus 5 over minus 8. So my slope is going to be 5 over 8. Okay, I'm going to do it again. And I'm going to say, well, I'm not going to do it that way. I'm going to call this guy x2, y2. And this guy I'm going to call x1, y1. I'm going to go the opposite way. Okay, so the slope is going to equal y2, 7 minus 2, divided by x's, x2, 5 minus 3. And I'm going to get 5 over 8. So in both cases, I got 5 over 8. It didn't matter who I called my x1 and who I called my x2. If I have 2 points, that's all I need to make a line, and I'm going to get the same slope as long as I don't mix up my 1s and 2s. So if I take a 1 from the top guy and a 1 from the bottom guy, then I'd be hosed. I get the wrong answer. But as long as I was consistent in what I was doing, it shouldn't be much of a problem. Number 15. I want to graph each line given the information I have. All right, so the line's going to go through 0 minus 3, and it's going to have a slope of minus 3/4. All right. So we'll go in and we'll make up a graph, and the point 0 minus 3, 0 minus 3, 1, 2, 3. All right, so there's 3. Okay, so the change in y, we'll call it minus 3, and we'll go down 3. 1, 2, 3. So I'm at minus 6. Change in x is a positive 4. 1, 2, 3, 4. So I have 2 points, a point there and a point here. And then I'm just going to draw a line between them, and I'm all set. Now, it'd be nicer if the line was straight, but as long as I don't declare what this is over here, I could figure out what that is, I suppose. If I went up 3, I'd go minus 4, so that point's going to be at minus 4. Okay, so that was definitely overachieving. Number 15. I just did number 15. Number 25. Okay, I got a line that crosses the y-axis at minus 2. So the y-intercept is at minus 2, and I've got the slope equal to minus 5, and I'm supposed to find the equation of the line. Okay, so y is equal to the slope minus 5 times x minus 2, the y-intercept. I was all excited there about getting the right answer so quickly that I bummed up the picture. Yeah, that's all there is, I know. It's pathetic, but just the way it is. 42. And they're not going to get any harder than that until we get to chapter 14 or so. 42, does it really go to 42? Find the slope and the y-intercept. Trick question. X is equal to minus 4. What's the slope? Well, this is a vertical line. What's the slope of a vertical line? It's infinite. It's undefined. Either one of those would be perfectly okay. And where's the y-intercept? No y-intercept. Oh well, could be worse. 42. 55. Oh boy. A metal rod is 43 centimeters long at minus 15 degrees. So I'm 43.0 centimeters at minus 15 degrees. And I'm 43.2 centimeters long at 55 degrees. All right. This data can be listed as follows. Find the slope as a simplified fraction of the straight line passing through the 2 points. Okay, well that's pretty pathetic. Why don't you just give us the numbers to begin with and tell us to find the slope? Minus 15, 43, 55, 43.2. Okay, and we'll call this guy the 1 guy, and we'll call this guy the 2 guy, and our slope is going to be equal to 43.2 minus 43 divided by 55 minus 15. 0.2 divided by what? 70? 0.2 divided by 70. And what did it want us to do? It wanted us to as a simplified fraction. That doesn't look very simple, does it? We'll call it 2 over 700. We'll call it 1 over 350. That looks like a simplified fraction. Does that look like a simplified fraction? Yeah.
So could you write it as just 350 and leave it at that, or no? You would have to have the 1 period.
1 over 350? Yeah. Yeah. You can't just leave it 350. That'd be wrong. That'd be the wrong slope. That'd be a huge slope. 1 over 350 is a very slim slope.
Okay.
Yeah. And when you get to physics next year, guess what you're doing? You're solving problems that expand, metals expand, and they have a coefficient of expansion, and how big is the hole, and yeah, you have that thing. Okay. With that, we will do a Control-Alt-Delete.